All right. It is 1 o'clock. We've got a bunch of people joining still. But I will get started. This meeting is being recorded, and I'll post it on YouTube so you guys could always be able to refer back to that. This is a smaller group of just the beta testers. So if you guys want, you guys can all unmute and ask questions or speak, or type them into the chat. Whatever, I'll monitor both. Just let me know if you want me to go into anything deeper, or if you have any questions or anything like that. Yeah, a lot of information to cover, so we'll get started. Okay, so I'm going to share my screen. And so some of this you've probably already seen from the preview video that I sent out. There's 2 new features coming out on this beta. It's an auto zoning function and a VAV auto select, and they kind of work together. You kind of have to have your zones picked before you can select your VAVs. So first, let's talk about the zoning tool, because you got to get all your zones in before you can get your VAV selected. So if we open up the VAV zoning tool, you'll see an interface here. So the first thing you have to do is you have to zone the air handling units. So all the VAVs zones obviously have to be on the same air handling zone. So you have to get air handling zones in before you can zone VAVs. And so the way we're going to do that was described in the paper that I sent you. And we'll kind of review that here, just to show you, what this thing is thinking. So the first thing that we care about when it comes to air handling zoning is, I guess I should back up and say, this is for VAV reheat systems. So this is a central air handling unit that's bringing in outdoor air, filtering it, heating, cooling it, and delivering it to multiple zones, multiple VAV zones that are then reheating the air. So this isn't zoning for like DOAS or any of the other kind of system types. This is just the basic VAV with reheat. That's what this is assuming. But a lot of the principles kind of hold the same. So the first principle that we're going to talk about with zoning is ASHRAE 62.1. So ASHRAE 62.1 says, every space type has an air classification, and you can't mix certain air classifications. Like, you don't want the smells from a cafeteria going back to the air handling unit, getting mixed with the classroom air, and then getting delivered all to the classroom air. So you need to segment your building by pollutant groups, essentially. Now, you could put like a cafeteria on a classroom air handling unit. You just have to then exhaust that cafeteria. Well, when you exhaust, you have to bring in outdoor air, and so it's a big increased energy cost. So, in my experience and through the, kind of the numbers I ran, it's about 4,000 CFM. Anything over about 4,000 CFM, you should be looking to put a dedicated zone. So if I had like, a real small, eating area, maybe that doesn't need a dedicated, air handling unit. I'm just going to throw it on the big central air handling unit, and then exhaust everything out of that room. So you have to group these things into pollutant groups. So you might have like a restaurant next to a bar. Well, that's pretty much the same pollutants. It's just food and whatever the restaurant is serving. So we're going to group those. So the way we're going to tell the software to zone air handlers like that is we're going to give it a dedicated AHU threshold. So this is a minimum AHU CFM. We're going to say 4,000 CFM. And then we're going to give it the groups that can be zoned together and see. And then so the software is going to go and say, hey, do I have any of these adjacent to each other? And if so, do the total CFM they need, is that over this number? And if so, we're going to give that a dedicated air handling unit. And so if we go through, we've got a dining group, we've got like an exercise group. You know, the weight room and the aerobics room have essentially the same pollutant groups. Let's put those on the same air handling unit if we can. Same thing for locker rooms, daycares, things like that. So that's how you kind of break off the class 2 and 3 pollutant groups and give those a dedicated air handling unit if necessary. So if they don't exceed this, then they're just going to go on the, you know, class 1 air handling unit, and it's just going to be assumed that that air is going to be exhausted. And this is just going to be a first pass at zoning. You could always go back and change things manually. This just gives you something in the model so you're not starting from scratch. So that's how we tell it. And then you could add pollutant groups, and you could add different space types to the pollutant groups. But this gives you an input for that. And these are the space types that get automatically assigned with the assign occupancy category. The assign occupancy category function that is back in the loads toolkit. So if you want to go back and look at the loads toolkit webinar, it's on my website. You can review that about how we get all these space types automatically assigned. So if we look at this school, you know, this is the cafeteria. We could see that, you know, it got automatically assigned the space type. Let's go ahead and run zone air handling units, because this takes a second to do. So it's got to go through, and it's got to figure out where every single, you know, what space is adjacent to every single other space. So it goes through and it builds that matrix. Then it runs through these air handling units or these groups, and it says, hey, do I have anything above 4,000 CFM, which this is editable, you could change this, that can be broken off. And then it takes the rest of them and it says, okay, I want a max of 15,000 CFM per shaft per floor. So then it breaks the floor up into 15,000 CFM chunks and groups those on top of each other. And the reason we do that, the reason we leave it to 15,000 CFM is you've got plenum height requirements that you're trying to hit. You don't want your plenum to have to be really, really deep, because the architect's not going to give it to you, and you're going to be running into coordination problems. So the way I kind of like to kind of think about like an example is like, think about a 3-story building, 45,000 CFM per floor. So you could put one air handler per floor and have that serve the entire floor. You know, one 45,000 CFM air handling unit serving the entire floor. The problem is when that duct leaves the mechanical room, it's going to be huge. It's going to be like a 28 by 112 duct. It's going to be giant. It's going to be really hard to route that thing. What would be better to do in a 3-story building with 45,000 CFM per floor is put 3 air handling units on the roof and feed shafts down, and each shaft serves 15,000 CFM out. And that's because you get a much smaller duct at 15,000 CFM. And that way your plenum heights could be a little bit or a lot smaller. So the reason I picked 15,000 CFM is because the target duct height that I like is 18 inches. So an 18-inch tall duct, you have to fit an 18-inch tall VAV in this plenum anyway. So making a really tiny duct doesn't really make sense because you got to fit the VAV anyway. And then if you stick with a maximum of a 4:1 aspect ratio, that gives you an 18x72 duct. And an 18x72 duct can carry 15,000 CFM at 0.1 inch water column per 100 feet. So that's like a reasonable target for how you should be breaking up each floor to be served with shafts from air handlers on the roof or the basement or an interstitial space. So that is why I picked 15,000 CFM as default. Now you can change that. So if you do want to do one air handling unit per floor, you could totally do that. You could totally put 45,000 CFM in here, and it will give you one air handling zone per floor. Then the other thing, and this kind of gets more into high rises, is maximum floors per air handling unit. So if you serve more than 20 floors with an air handling unit, the shaft is going to get so big that the shaft is going to be almost the size of a mechanical room anyway. So you want to put a limit on that, on how many zone or how many floors you want to stick with the zone. And this typically high rises anyway, because the structural system requires belt walls, which makes some floors not usable anyway. So typically you just put your mechanical room on the belt floor level, and then you serve up and down to the nearest 20 floors. But these are all editable. And then even once you do all of this, and let's put the air handler zone here, you could still change these things manually. So this is how the software zoned the building. It said, hey, this cafeteria and the adjacent similar pollutant groups, and there's a cafeteria right above this on the second floor. Let's see over here. Put those on their own air handling unit, because they have more CFM than 4,000 CFM. Now, if I say, hey, I know I put 4,000 in, but I don't like this, I want to change this back to a different air handling unit, no problem. You can just select those. Select those spaces, and let's see, that's dark blue is 4. And I could just say, the zone is only being set by just a parameter. So it's just HU zone parameter. So let's just make all of these 4. Oop, did it take? Yeah. So you could zone these manually. You can use the zoning tool as a first pass. It's really however you want to do it. But the zones are all defined by just a space parameter. And it's a text parameter, so you could call it what you could call the zone, the air handling zone, whatever you want. And this, to me, I kind of judge these automation tools compared to like how I would do it manually. And when I go through these example projects and zone these things, it really does a good job of looking how I would do it manually. For a school this size, 4 air handling units seems reasonable. It just looks like what I would do. Now, maybe I can't get the architect to give me a separate mechanical room for a cafeteria. And since there's nothing on the 3rd floor, I might have to say, hey, these are going to be, part of this, but at least I've got some place to start. And I'm not starting from scratch, getting all my zoning in there. Now, VAV zoning for schools is not very exciting. It's basically everything gets its own VAV zone. So I've also done just like a office tower floor here, just to kind of show you. So this is how it's zoned the uh, um, floor. You know, it all things being equal, it's going to try to keep you on an east-west axis to get the most diversity out of your air handling unit. So, you know, sun in the morning here, these are going to be peak load, and then these are going to be peak load in the afternoon, so you get more diversity. But it just splits things up as equal in CFM as necessary. So this will be a little bit more exciting for the VAV auto zoning. Okay, so the way we're going to do VAVs, and again, this is all described in the paper that was attached to the meeting invite, is that ideally, you know, if cost is not a concern, there is no VAV zoning. Every single zone just gets it, or every single space just gets a VAV. That way you've got, you know, perfect temperature control in every single office. Now that gets a little expensive because it's a lot more VAVs, a lot more controls, a lot more piping. You know, so almost always you are grouping offices together. But you're when you do that, you're sacrificing comfort. So ideally, everything on the same VAV zone has an identical load profile. You know, throughout the day, it's getting hit exactly by the same sun. It's got the exact same people using the exact same lights, the exact same computers. Functionally, that just never happens. So somebody is always on vacation and they've got the thermostat and the person next to them is uncomfortable. So it's always going to be a trade-off between cost and comfort. So knowing that we're not going to match the load profiles exactly, the next best thing we're going to be able to do is match the load. So, you know, you're going to have to allow the load to vary a little bit, but you shouldn't allow it to vary by very much. So my default out of the box zoning rules is that zone offices, 3 offices together if they're within 15%. So that's going to keep, and I guess I could let's just hit this and just show how this works. This one's a little bit quicker than air handling units. Again, this is just a space parameter. That's the only way the zone is defined. So I said zone up to 3 VAVs together if their loads were within 15%. And this is heating and cooling loads. So for an office, it looks like this. So, hey, I had 3 offices next to each other, and they all have the same load because they've got the same exposure, they're the same size. And then I've got 2 here, I don't have a third. Now this office, you'll see, is like a little bit bigger. So this is outside of 15%. The load is different. So it says, hey, you get a separate load. But then it looks like, hey, what's adjacent to this? Oh, it's a corner office. That has a way different load because it's corner. And that's how it kind of zones these offices together. You know, these all have a similar load. Break them up into 3, 2, 2. Conference rooms all get, because it's not an office space type, it all gets a dedicated air handling unit. So right now, the only out of the box rules I've got is office space, which you zone with a similar office, zone up to 3, and zone them at 15%. Corridors can be anything, zone all the corridors together. A lot of times architects take their corridors and kind of make 2 corridors that are really one continuous space. So just feel free to zone those together. And then the same with storage rooms, but storage rooms, it doesn't have to be the same space type. It could just be any adjacent space type. Just take the storage room and zone it with a adjacent space type. And those are the only out of the box rules I have. And you could obviously add more rules, you know, with different space types. And if you guys have zoning rules that you think would be great to add as defaults, I would love to hear them. Shoot me an email or or reach out to me somehow, because I'd like to I'd like you to open this up and it be kind of ready to go with how you would typically zone these things. And then there's a clear zoning button if you just want to start from scratch, you can clear all the zoning. So it looks like we've got a hand raised. Matt Houston, I think you should be able to unmute yourself, or you can type in the chat, whichever one you prefer.
Yep.
Hey, Matt.
I got you, Kevin. How you doing?
Good. How are you?
Doing well. Hey, question for you. I may have missed this because I've been half distracted by trying to see whether or not West Virginia is going to beat Maryland on this opening game of the bracket. This zoning map is fantastic. I love the colors. I love the way that it breaks it apart and everything. Is that part of this package and this beta test as well? Do you have that ability to create that?
Yes. So when you install the tool and you open this, it's going to automatically import a couple schedules for you. And one of them is going to be your ventilation calculation, your space ventilation calculation zone. And this is going to have two new space parameters attached to it. It's going to be your ripple-HU zone and ripple-VAV zone. And so what the zoning map is it is just if you go to analyze color fill legend, you drop that on, and then you pick what parameter you want the color fill to be by, and you could pick the air handler zone or the VAV zone, and that's how you get the color mapping to work. And
I had.
Go ahead.
I'm sorry. Go ahead.
No, you go.
So one of the things is having both of them is good. Don't get me wrong, but I've had clients in the past who want to know what are my VAV zones and what is my air handling zone. And getting into big buildings, they have to flip back and forth between multiple pages.
Yeah.
So one of the things I've seen before, and I know this is a bit problematic, is there a possibility that in the VAV zone mapping, that you could have it trace an outline in a specific color of all of the zones that are tied to an air handling unit?
Yes.
And that way, then we'd be able to see not only the VAV zones, but what VAV zones apply to which area.
Yeah, that would I totally see the use case for that. I don't know if you could do that, but
I think it's a programmatic thing. I don't know that that's a built-in Revit thing.
Oh yeah, okay.
It takes a little bit more effort.
I was hoping this would hatch the air handler and color the thing, but no, that's expecting too much. No, let me look into that and see what you could do about that. I don't know a good way to do it off the top of my head, but let me think about it.
No, this color coding is fantastic. This is a great way to communicate with clients about what zoning we're intending to use so that they can sign off on it before we get too far into the weeds with it. So I like that a lot.
Yeah. And it's also helpful, like I found it's helpful, and you'll see this a little bit more when we get the VAVs dropped in, but it's helpful when you're designing too, to know, like just being able to turn this on and say, oh, these two are on the same VAV, I need to get duct here.
Absolutely.
But yeah.
Agree 100%.
I think it's real helpful for designers, and then you could even make your own separate sheet that's just zoning, and you just have these view schedules or these view schemes turned on. But yeah, I will look at, let me write this down. I'll look at HU plus VAV zone, because that would be nice to show on one sheet how you could do that. Oh yeah, Alex says you might be able to drag two views onto one sheet and overlay them. Yeah, and yeah, you could even do, yeah. That's a good idea. I'll have to continue to think about this a little bit. Yeah, fire protection does something similar, yeah. Okay, I think I missed a question from Scott. Could there be an XML file that we could share for air handling and VAV settings? That way we could pick up. No, so I don't. That's not built-in functionality now. The zoning rules will. Oh shoot. No, of course. I was debugging this and it not like that. The rules will stick, but they'll stick on your machine. So again, that's if you have rules that you like, send them to me and I'll just make them default as part of the package, and that way, you know, we can share them. And you have and everyone who downloads a plugin will have that, and your whole team will have that. But as of right now, there's no way to like share rules across a company. Okay, let me go through the questions. Okay, I think that's all the questions so far. Okay, let me go back to here. Okay, so do we get our VAVs? Yes, okay. Okay, let me. These are VAV selections from previously. Let me just delete these out of here so we can get new ones. So that is zoning. So I tried to describe this the best I could in this paper that I sent you guys. If you have any questions or any other thoughts, this isn't in line to be published yet, so I can make any modifications to this. So any additional thoughts on this, feel free to reach out and let me know. I'd love to hear any feedback on this. Okay, so now to VAV selection. So now we've got our VAV zones. Now we could do our VAV selections. So we're gonna pop this open. And we're going to, when you pop that open, it's going to import your the families that you need. And again, just like the diffusers, these call to specific endpoints on Price's cloud-based selection software. So it's got to be these families. Because this is the only way I can make Revit understand how to talk to Price. And these are automatically imported along with the VAV schedules. One for electric, one for hot water, and one a ventilation schedule that we'll talk about a little bit later. So the way these are selected is what we kind of explained, or I kind of explained in the paper. There's a lot of different ways to select VAVs, but to automate it and to get something in the model, you kind of just have to pick one and go with it. And I kind of laid out my reasoning for why I picked this one in here. Basically, I select them based on the discharge air temperature. But then I keep the, leaving water temperature in check, and I'll show you how I do that, along with the noise criteria. So this is going to take, a lot of the data we need to select the VAVs are in the space. So ventilation data is in the space, load data is in the space, and airflow data is in the space. So those are the things you need to select the VAVs. Specified supply airflow, load calculations, well, really just heating load because you got to size your reheat coil. And then the space type, because that holds your ventilation data, and that's what sets your VAV minimum. So if you have these things set, then you have the data from each zone to be able to feed into Price's online selection software. Now, you still do need a lot of other information, and that's what this is for. So for instance, you need to tell it, do I want hot water or do I want electric VAVs? You know, that's the first thing you have to tell it. Then you have to tell it, hey, do I want to provide reheat coils on internal zones? So the VAV minimums are driven by ventilation, not by thermal load. So you could have one person in an open office, and if you don't have a CO2 sensor in there, you're going to be going, you might be delivering 1,000 CFM for one person in this open office, which you don't want. So I always provided, 1 row coils on internal zones just to temper that air. But if you don't want to do that, if you just want no coil on interior zones, you could uncheck this. Air distribution effectiveness. Again, this affects your VAV minimum. So you are able to put that in here. I typically use 0.8 for heating and 1 for cooling. Now, if you're going to go through and get, low returns, then you might be able to turn this to 1. Override VAV entering air temperature 2. So by default, you've got an entering air temperature in the space, because that's what I use to calculate the specified airflow. So you can use that, or you can override it. And this is to account for, like if you're going to do a discharge air temperature reset on an air handling unit, maybe you want to size all your VAVs at 65 instead of 55. And that way you can just check this, click 65, and that way all your units will get sized at that VAV entering air temperature instead of what's in the space. And then what height do I want the VAVs to get dropped in? So the VAVs are just going to get dropped in above one of the spaces in the zone. And this just lets you give it a height. It's probably going to have to be changed after it gets dropped in. But this is just so you could know where to expect them. We've also got an input for demand control ventilation. So since we already have all this data in the space, hey, that's, if we need demand control ventilation, let's get that put in there, because that affects the sensor type that's going to be on the VAV schedule. So might as well say, give some logic behind getting CO2 sensors in there. So International Energy Code, I think, is over 25 people per 1,000 square feet, and over 500 square feet, you want a CO2 sensor. And we're going to say the ambient CO2 concentration is 400 parts per million. That's going to affect my set point. Then the other option here is reheat, demand control ventilation space, max flow to neutral. So if I have like a space that needs 3,000 CFM in cooling and 1,000 CFM in heating, if I don't have this checked, it's just gonna meet the heating load for the coil. Now, if you have demand control ventilation, sometimes you have way more airflow than the thermal load, because it kind of decouples your VAV airflow from the thermal load and attaches it to the CO2 load, which might not interact. So like if it's the dead of winter and you've got this conference room and it's 0 degrees outside and you've got 10 people in this conference room, there might not be any thermal load in the room because all the heat in the room is getting sucked out through the windows, but you've got a ton of CO2 in there, so the VAV goes to maximum, and that might freeze out your conference room. So if you want to say, hey, size the coil to assume that this is going to go, if I've got a CO2 sensor, it's going to go to max, you can do that here and just click that. It's kind of user preference. I've done this before, but I've also found that as long as I'm getting a reheat coil everywhere, I can at least temper that air and it's typically okay. It's really up to you. It's just a feature that you can have. Typically leads to bigger reheat coils, bigger VAVs, but at the cost of comfort, like everything we've been talking about. So then for hot water, we got to feed some additional data in there. Data from the spaces plus this data allows you to get a selection back. So maximum leaving air temperature. This is what we're going to select it based on. So ASHRAE 90.1 says keep it within 20 degrees. Ashtray 62.1 can give you a bonus here if you keep it within 15. Now that 62.1 also wants you to maintain like 150 feet per minute at 4.5 feet, which is drafty. And so I never like doing that. I just allow this to be 0.8 and allow the nice warm air to get in there. But this is the maximum leaving air temperature that the VAV is going to be sized to. It doesn't mean that this is what the VAV is going to be sized to. The VAV is only going to be sized big enough to handle your heating load. So if I could do that with 80-degree air, it's only going to size the VAV at 80. But this is the maximum. So once I reach 90, I start to boost the reheat airflow to keep the maximum discharge at 90. So that's how this is going to work. This is going to be your absolute maximum. The other thing we're going to set is a maximum air pressure drop. So anything over above a 1/2 inch, it's going to move to the next size up. Next thing is the minimum air velocity pressure that you can read. So this might set your VAV minimums. So this is basically does not come from the VAV manufacturer. This comes from the controls manufacturer. So it's how low can their pressure transducer read, attached to Price's air sensor. What is the minimum airflow that you could read? And that allows you to set your VAV minimum. So if your ventilation minimum is below what you could read, you set the minimum to what you could read just to make sure that you can get your ventilation there. Now, modern VAV controls and pressure transducers are reading down to like 0.001. And that's kind of gone over in the paper too. So this rarely drives your minimum, but I just like to put it in there just to show everyone the calculation and why things are being picked where they are. Again, maximum water pressure drop. You don't want to drive the head too far up on your pump, so we'll set that at 5. Heating water supply temperature, this is set by the boiler system or the heat pump system or whatever is making your hot water. I like low temperature hot water systems, condensing boilers, heat recovery chillers, heat pumps, those all operate at low temperatures, which is why this is so important because back when we were putting 200-degree water to all the VAVs, VAV selection was not very important. A 1-row 200-degree coil was going to give you all the heat you needed, no matter where you were. With 125-degree water, that's way different. So that's why that's important. And then because we're selecting these VAVs by discharge air temperature, we can't pick the return water temperature exactly. So with VAV coils, you've got really a handful of options, 6 options, I think. You've got 1-row, 2-row, 3-row, 4-row, and then you've got on the 1-row and 2-row, you've got 10 fin per inch and 12 pins per inch. So you can't make the air side BTUs equal the heating side BTUs exactly because you only have 6 options. Now, you can do that on like a air handler coil because Trane or whoever will like custom build you a coil to match your performance exactly. That makes sense to do on a $200,000 air handling unit. It doesn't make sense to do on a $1,000 VAV. So we just give it a maximum heating water return temperature. So give me at least a 25-degree delta T or a maximum of 100 degrees. That way I get that nice low water temperature back to my boiler. Boiler's in condensing mode. We're all good. Now, you don't want to put 4-row coils on a little tiny 4-inch VAV. So below like a 1/4 GPM, don't worry about this and just let it do whatever it wants. Fluid type, glycol percentage, if you have glycol, which liner you want. So this is typically kind of standard for the company. They kind of always go with whatever it is. The default is the foil-faced board, but you can change this as necessary. And this is all the acoustic stuff. So what's your assumed inlet air pressure? What's your assumed discharge pressure? And what's your maximum NCs? These typically don't drive the box size. It's typically this. Typically, the air pressure drop is gonna drive the box size. But you want to keep this in check, especially for no coils. Couple other options that price allows you to select is oversized casings, and which are, you might have a 8-inch inlet with a 10-inch casing on it. So that gives you a smaller inlet, so smaller minimum, a lot more controllability, a lot lower minimum with a big coil on it, low pressure drop, higher delta T's. So this is a really good option. And then high capacity coils just bumps from 10 to 12 fins per inch. That's another one, good one to check. And then allow even size only. So I think you could order like 7-inch, 5-inch, 7-inch, 9-inch. And I like to allow the odd sizes just because, again, more controllability. You could read them. They could read down to a lower airflow. So I'm going to go ahead and batch select these. And I think we're getting, if anyone has to jump off, this is being recorded and I'll post it to YouTube and I'll send it to everybody. So if you have to jump off, I'll send you a YouTube link tomorrow. Okay, so this is, grouping up all the VAV, all of the space data, combining it to make a zone, combining it with this information, feeding it up to prices, selection software, and it's making a VAV selection for every single zone. And it comes back and it drops the appropriately sized family in to every single zone. So like I was saying, it's nice to have these zones color coded. So now, bam, I know this serves these three. And these come in with all of the information that we put in here and all of the information from the space put into this VAV. And it comes with this schedule. So this schedules everything as it's shown here. It's a smart linked schedule. So and this, my thought here was I'm just going to flood this schedule with information and then let you pare it back as needed. So let's just go through it. So it copies all of the space names, which come from the architect, copies all those into the VAV. So it copies the air handler number into the VAV. The model and manufacturer, the Autoselect will come back to that, inlet size, casing size, the weight, your controllable minimum here. Here's what I was talking about before. It's nice to be able to know what that number is. So you can compare it with your other numbers. It copies the air distribution effectiveness from the input from the UI. So you've got that here. And then it calculates what the area, what the population of those spaces were. And that way it could calculate your minimums. So your economizer minimum, your minimum when you're not an economizer, your maximum, and your same thing in heating. So this is going to be a little bit higher because you've got worse air distribution effectiveness in heating mode. And so here's an example of the heating minimum for ventilation was 2760, 2765. I bumped that a little bit. Now at this, I don't need 90-degree leaving air temperature to meet the load. I only need 77, so it just sized it at 77. So you can kind of see where the minimum is exceeded. So like this one is 90 degrees. I had to go way above the ventilation just to meet the heating load. It gives you detailed coil selections. So what's your real leaving water temperature? What's your real GPM? So you could really get, hey, what's my boiler entering water temperature? What's my real pressure drop? Rows, fins per inch. So it picks the smallest inlet size and coil size to meet that, zone. Handing follows on the, let's see, handing follows on the family. So if I say, I want this to be a right-hand coil or a left-hand coil, I click that, and then let's say I want this to be a left-hand control enclosure. I change those. Now those, changed in, so here those are right there. So now your hand is synced with your family that's shown on your plan. And that way, this just makes the middles go quicker. And if it's, if it's on the plan as left-hand coil, it's on your schedule as left-hand coil. And same goes with the control box. All of your acoustics data is in here, and this can be modified. If you actually have a different inlet pressure and outlet pressure, you could really dig into the details of what the discharge NC and radiated NC are and all the octave bands are. Your sensor, like I said, we told it when we wanted to provide CO2 sensors, and so it did. It said anything above 500 square feet and 25 people per 1,000 square feet gets a CO2 sensor. Bam. It told us what we needed. And then it also gave these set points. So these set points come from this space type additional data schedule. So this says, hey, by default, what do I want the cooling mode set point to be in occupied and unoccupied? And what do I want the sensor type to be? So if you change this, let's say like a cell from an S to a V, now when you run the VAV selection for a cell, it's going to, instead of giving an S, it's going to get a V. And that's all described in kind of this paper as well, what the sensor types are. And you could change if you have a different standard for sensor types, you could change them. You could hide this row, you can do whatever you want. Same goes for the CO2 set point. It gives you a calculation of what the CO2 set point is based on the metabolic activity from the space type additional data. So it's really putting a lot of data to work that you've already put into these, that you or even the architect has put into these spaces, and feeding it through to the family. Same goes for electric here. So electric obviously is a lot. It's none of the same parameters for none of the heating water is there. Really what it comes down to for electric is what's your electrical system, what's your controller, and when do you want to provide what phase. And this is typically a conversation with the electrical engineer. Like at what kW do you want me to provide what voltage? And I think typically this is the way it works, is anything under 4 kW is 277 and everything else is 483 phase. If you have a 480, 277 building, if you have something different, if you have like a, residential type, maybe you're doing 120, 240, just however you want to do that. And that'll set your coil, that'll set your voltage on your family up. But before we do that, let's go back to, so the other thing that this does is it moves with this hot water coil, you'll see that it moves a lot of the information, like your ventilation information. It moves it to the VAV because that's what sets the VAV minimum. So now you could have a VAV schedule. So this is a schedule of the VAVs, but it's got all of the ventilation information on it. That way, now your ventilation information, instead of being stuck on your spaces, it moves up to your VAVs because you own this. Whereas the spaces, you always have architects deleting walls, your space goes to zero area. There's just a bunch of problems with keeping your spaces up to date. So my goal is kind of to, when you start a new project, get your spaces placed, get the occupancy category, get the loads, get everything really quickly, and get to your VAV selections, and then you don't need your spaces anymore. If your spaces get blown away, there's no information here that I need anymore. I already have my VAV selected, and I already have all the information from my spaces on my VAV. And I truly own these. I don't, like, the architect's never going to accidentally delete my VAV, but he is going to mess with my spaces all the time. So that I'm hoping, I understand spaces are frustrating to work with, so I'm hoping to, hey, you only need them for a very short amount of time. So that's what this VAV ventilation schedule is. It's basically a ventilation schedule, but on your VAVs. So these are just your ventilation parameters written to your VAV. What I would suggest doing, so you're probably never going to put this huge schedule on a sheet, although you could. I would suggest duplicating this. And then, call it like hot water coil print schedule or something like that. And then make it look like how your company typically schedules these. So like I never scheduled, the liner went in the spec, and I never scheduled any of the acoustic stuff. So I would typically just hide that. Same thing goes for set points. You can group these by space type, put them in the schedule, whatever you think. You could just start getting rid of these and making it look much more like a schedule that you would print. You'll also notice that these are, some of these are highlighted yellow, and these are highlighted yellow because these are selection parameters, meaning when you change them, it changes the selection. So we selected everything for 125 degree, and everything came from the hot water. Now, let's say we have a wing or something that's served by an existing boiler that's 180 degrees. We can go ahead and change, let's say everything on air handler 1 and 2 is served by an existing boiler system. And so we'll look at the sizes of these and the coil counts, fins per inch, GPM. But let's go to a 3D view. And so we've got all 29 of these VAVs selected. Let's say these are actually at let's say these are actually at 140 degree entering water temperature. So what this is actually going to do is it's going to go up now, and it's going to recall the selection software and reselect all these coils at 140 degrees, and then modify the family, the family size, the coil count, the GPMs, modify everything in there so that you'll get a good coil count. So we've got so these switch to smaller VAVs. And we've got different different GPMs, different pressure drops, everything updated, and almost everything's like a 1-row coil now. So, and you can do that with anything in here. If you have a different max water pressure drop, if you want some to be 3.5 instead of 5, or 0.35 air pressure drop, you can modify these things, and these VAVs are still linked to the price selection software. Okay. What am I missing here? Oh, electric VAVs, we could look at those coils or look at those selections. So if we switch to electric, again, it's going to do the same thing. Pick the smallest neck size that works given these inputs. Oh, I accidentally picked it on a 240, 120 system. That's okay. A little bit simpler schedule here. Electric coil, so you'll see anything. Oh, looks like I've got an issue with one of the 24x16s. Anything above, let's see, what do we say, 1.5 kW is 240, anything below is 120. And that's how these work. Yeah, so looks like I've got an issue with the 24x16 that I'll get into. So this is early access beta. There's going to be a couple bugs. Please shoot me an email, and I will try to get things updated every week. Crushing the bug. So as you find them, let me know. Trying to think if there's anything else I'm missing. I'm sure I'm missing a ton of stuff. If you guys have any more questions, feel free to reach out. But yeah, are there any more questions? Okay. Is it possible to still link entering water temperature and entering air temperature to global parameters, or does automatic call to the price selection software have an issue? Oh, global parameters, that's a good idea. So I think I haven't done a lot of work with global parameters, but I think you can. So as you create the model, I think you might be able to link these to global parameters. I'll have to look into that. I haven't thought about that a lot, but that is a good idea. Because typically your heating water temperatures are global. Okay, feel free to jump in, anybody.
Hey Kevin, this is Ben. I have a question.
Hey, Ben, how you doing?
I'm doing well. How about yourself?
Good.
Do these schedules also, like if you were to go into the view palette, and then if you go into user interface and show your system browser, does the VAV schedules also populate like for Revit systems?
I don't know. So if you go to view, user interface, system browser, how do these all show up? So these are all going to be unassigned.
Okay.
And what's worse is they're going to be unassigned. Each one is going to have each heating water is going to have 3 unassigned systems. An air system, a hydronic supply, and a hydronic return. I guess that is a good thing to point out, that the connectors are all set up right. The pressure drop is assigned to the connectors correctly. So you've got, half the pressure drop on each connector. So you can do piping pressure loss calculations with these VAVs. And the system packs will be set up right, but they won't be assigned to anything.
Okay, so then
all
that
this
would
is gonna,
still be done. Okay.
yeah, all this manually, although that is something that would be nice to have that just automatically, hey, create an air handling system and assign the air connectors to that system. That's a good feature. I can't promise on when I'm going to be able to deliver that though, because
Oh yeah, no worries. It was just a question because yeah, if you create spaces and say if you put like air registers in the RCP, you can link those registers to a system, right? And it tells you on the side of that project browser, hey, this air handler serves these spaces. This is a total CFM for these spaces, so on and so forth. So I just thought maybe that did that already, but
no. Okay. No, I'll tell you what, I will definitely do that after air handlers are auto selected and dropped in, because that would make sense to have literally everything on one system. Just your system browser is already set up and everything would be assigned to the right system.
cool. Thanks for taking the question.
Anytime, Ben. Would it be possible to add a minimum leaving water temperature for heating? Kind of. So that is what, when we jump into here, so this provide reheat coils on internal zones. What this is going to do is it's going to size the coil just to bring the room up to neutral, which is the space temperature set point in heating. So that's typically 70 degrees. So that does kind of give you a minimum leaving air temperature of, hey, at least bring me up to the space temperature, even if there's no heating load in internal zones. So let's look at the hot water coil and like what that did. So some of these offices are internal, and where's my discharge air temperature? Leaving air temperatures here. So some of them are external and they need like 89, 90 degree discharge air temperatures, but some of them only need 70 because these are internal. So that is a way to set a minimum reheat coil. Hopefully that answers your question. Oh yeah, okay. Instead of 70, hey, maybe we bump this up to like 75. You know what probably a good spot for that would just have another checkbox and a box here to say, what this temperature is. But then if you had a space temperature at 72 and this at 70, which one would it go? Let me. Oh, and then the other thing you could always do is you could say, so because leaving air temperature is a selection parameter, you could say, let's sort this by leaving air temperature. And so anything that was 70 or below, like a storage room, these are all, or if you want to say, hey, minimum is 75, you could select all of these, go to your 3D view. Now I've got these 20 selected, and then now I need to go to leaving air temperature. I'll set this to 75. Oh, sorry. Okay, let me back this up. So what I'm gonna do here is if I wanted to say, here's my hot water coil. So if I wanted to say, hey, minimum discharge air temperature is 75, I could sort this by my leaving air temperature. I've got the 24 by 16s are messing up for some reason, but I could select everything that's below this. I could go to my 3D view. Now I've got these all selected. I can go to my leaving air temperature. And then this will call back up and it'll reselect the coil for that slightly higher temperature. So that way you can have, you know, storage rooms at 70 and offices at 75 and everything like that. And that'll, again, automatically update the GPM, the coil rows, everything you need, given your other inputs. Yeah, it's a way different workflow when you link everything live to Revit, because it's just a lot quicker, a lot more dynamic. You can make changes quicker. You can, you know, when you can batch select 100 VAVs and it only takes 30 seconds. Well, hey, now I can try 140 degree water and 120 degree water and see which, you know, it's just, there's a lot of options available when you start linking all this data together. Okay. Thanks for coming, everybody. I hope you liked it. If anything else comes up, give me a shout. All right, thank you.